Hi, this is Brian from Let's Code Physics. I sat down with Brad Moser of Physics Alive in Hamilton College and Ann Leek of High Point University to talk about our reflections on the 2022 winter meeting of the American Association of Physics Teachers. In the 2 hours we spent recording, topics included quantum mechanics, board games, quantum mechanical board games, representation in physics, and what we hope to see in future AAPT meetings. I've split up this conversation into 6 bite-sized episodes that we hope you'll enjoy.
All right. And do you have a particular session that jumped out with something that you want to share?
Yeah. So this time I ended up going to a lot of the equity and diversity sessions. I tend to go to all the career sessions, which is really fun. Like the sort of lab science ones and like what are we teaching our students. But I'm starting a project with trying to get better mentoring support for Hispanic students, and we're in the final stages of grant approval, so fingers crossed.
Oh, nice. Yeah, definitely.
And I figured for that project I need to really brush up on what's happening in diversity and equity in physics. So I went to a couple of really fun sessions there, and one of them was actually super interesting because it was Ida Rodriguez was talking about different kind of conceptual ways to think about physics for underrepresented students. And they specifically came from her Hispanic heritage. So it was really cool. One of them was Nepantla. And I don't know if I'm going to do this justice, so I'll try. But basically, it's this in-between state or in the middle, kind of that feeling when you're not quite in one world or another. And I thought it was a really interesting way to think about students who maybe don't feel like they fit into physics, but they're sort of in physics, but then they maybe don't fit in with their families, their home or friend groups because they're weird physics thing, or, I mean, you could use it for all kinds of thinking and research. And I thought maybe it would be a valuable tool in the mentoring space, but also in my research. So Napantla, the in-betweens. That was fun.
Mm-hmm.
I thought that was someone's name. I'm so sorry.
Yeah.
Maybe their name is in between. They're
maybe
who they are.
What was an example of a strategy or some sort of, I guess the word intervention is used a lot, that you could use for an individual who was feeling like they're in this in between place? It's like, how do you help them feel more part of the physics world or the other worlds that they're feeling sort of left out of?
Well, maybe it's just the idea, from what she was saying, that you don't have to go over and help people cross the bridge. You can actually have a two-way conversation and a two-directional. So like valuing your students' ideas and perspectives and what they're bringing, even if they're maybe different from the norms of the physics community and vice versa. So it's not so much like we need to go help all these students. And I think that was also kind of, touched on it was definitely talked about in the plenary talk with James Stith too. The idea that we don't just want to keep helping the victims. And I think this Nepantla concept is really like, they're not victims. They're in this in-between world and they have things of value to share. And we're in these in-between worlds too. And if we can kind of cross these bridges, instead of helping victims into physics or from leaking out of a leaky pipeline, maybe building these bridges is a better concept. So Nepantla instead of leaky pipeline. That's what I'm going with.
Mm-hmm. It reminds me of you brought up James Stith's talk, and one of the statements he said early on that I wrote down that was meaningful for me was, what we do speaks so loudly that they can't hear what we say. And yeah, if we put out there this energy and this intention and this demonstration that we're willing to listen to everyone and what they have to say and value what they have to say, right there, what we've done is hopefully making that much more welcoming of a space. Hopefully.
One way I heard it said, this was in the context of computation, but I think it applies to physics as well. They said, your job is not to airdrop physics into these students' lives. Like, oh, look at those engineering majors, look at those chemistry majors, or look at those victims who aren't, welcome in their world, whatever. It's not our job to just fly over and say, here's some physics, have a nice day, hope it works out for you. But to actually go in and ask the question of, how is this useful to you? Like, what resources can I help bring that is helpful to you where you are in the things you are trying to accomplish in your trajectory, as opposed to saying, well, I'm either airdropping it or I'm taking people along my same trajectory with me.
It's very powerful, but yes, I would agree completely. I think, it's almost what we learned from the international development world, what you were saying, like, you just keep giving resources. You're in the relief organizations, but you're not in the sort of sustainable development space. And we can provide relief, or we can actually make systematic long-term changes, but that's going to take a shift in mindset. And I think the plenary talk by James Stith was very powerful, because he's been doing that work for so long and he's seen the shift. So hopefully the shift continues in a good direction.
Although he made the other interesting comment about, don't make DEI our next physics fusion, where it's always 30 to 40 years in the future where we've actually made it to the place we want to get to.
Yeah.
So Brian, do you have any talks that jumped out at you that you'd like to share?
So y'all were talking about the careers session earlier, which is wonderful and amazing. And I was in a teacher recruitment session, so also about careers along a specific path. But one of the things that they brought up, this was two invited sessions, and one of the things they brought up was a lot more students are interested in teaching physics or teaching STEM than we think. It's just that they opt out of that path very quickly, either because they get some negative perceptions of the career and what it offers and what it requires of them, or there's a representation issue where they don't see people like them in front of themselves in the classroom. One statistic that was really powerful, and I will include a link to this PowerPoint in the in the show notes whenever we get this published, so that you can actually see what it looks like. But they showed the sort of racial, here it is, I finally found the slide. They showed the racial diversity among the US labor force and among teachers. And US labor force, white non-Hispanic, is 67%, right? So already a bit distorted there. But among teachers, it's 79%. And so the teacher workforce is wider even than the American workforce overall. But then when you go to which students are interested in teaching, the non-white students are much more interested in terms of percentage of the population. They are much more interested in teaching than the white students are. And so somewhere along the way, we are losing these potential future teachers, as an example of this need for improvement in DEI. And so they were saying, so when you are going in and trying to recruit your high school teachers, it's even more important, that you keep an eye to the diversity of your student pool, of your recruitment, of your applications, et cetera. They also talked about how if a student takes a physics class from someone who had a physics degree, they are much more likely to go on to STEM in general, not just physics, but any sort of STEM field. And so I think it was something like 2/3 of all high school physics classes are not taught by people with a physics degree. They're cut thirds. They're being brought on loan from math or chemistry. And they said physics has remained pretty steady along that. Math is actually deteriorating on that. And so more and more math classes are being taught by people without a math degree.
Yeah, I was sitting in on this session as well. And some of those statistics were kind of mind-boggling. And Wendy Adams did something really cool where she had clicker questions where we all were trying to enter answers into the chat. So I appreciated that. And I got at least one of them wrong, that second one where it was, what do underrepresented folks, are they more interested in teaching or less? And yeah, the numbers were kind of staggering there. How many were really interested? And, I wonder if there's something culturally there that there's now I'm going to try to make broad generalizations if I'm not careful here. So I'm going to stop.
Yeah, no, I mean, DEI is such a rich, interesting field to look into, but then the DEI of the teacher profession, like, do the same trends hold, or is it its own different problem with different considerations? And so they gave some practical advice about how you market this, how you market a teaching career. They gave some advice about getting your colleagues on board, because when your colleagues are making disparaging comments about the teaching profession, that it sends those students off to a lifetime of research that they might not really be interested in. One of the things they talked about was, when you talk about teacher salaries, talk about the range. Don't show the average, because the average is skewed toward the newer teachers who are not making as much.
And probably not in STEM fields. And
also talk about the couple extra hours that teachers can put in each week for coaching a brain brawl, for coaching some sort of academic competition team, for coaching the physics club that can get them an extra few $1,000s a year to do stuff they're probably already interested in. And like, that can be enough to push the threshold of, no, wait, this is actually a livable career for me. Disclaimer, obviously we need to pay teachers more. That is definitely a systemic issue, but it doesn't have to be this barrier that turns students away, that there are ways that they can manage that better than is revealed in the narrative, I think. So that was interesting. In my institution, we technically have a pathway for people who want to be physics teachers, but there's really no recruitment to it. And there's nothing like there is no physics education class for them. It's literally, we'll get a physics degree and get a teacher certification. And so that's part of what I'm looking into, is, can we actually make a physics education path? And then we need to get the students, to go into it.
It's funny, we're actually working on a physics education path too. You would think we would have one with Aaron Titus. We've got a really great physics program. We've got an amazing STEM education master's program, and for elementary. I think we're one of the few universities that has an elementary STEM program at my university, but we still don't have a physics pathway, because the way the courses line up, it's hard for them to finish in 4 years with physics and get the license. But it's not going to stop us. We've got some ideas.
Yeah.
I think, part of it's rethinking the structures to make it work.
Yeah.
What I was going to bring up that's kind of interesting, because it's not physics teachers, but our elementary teacher programs, the one that students go into as part of their 4-year university track is not very diverse. But the one where we recruit professionals in different fields and actually bring them in to get a lateral entry teaching credential is much more diverse. And it's something I think we should look into more with physics teacher recruitment, especially if you have a physics background, and if that's going to help your students so much, is we should be recruiting from, industry, from technical fields. They should go into the classroom at least for a couple of years. Make some new physicists. Support more diversity. But our group that is lateral entry is much more diverse. It's called the Prepare program. And I'm sure it would be the same if we did that for physics teachers.
I'm just thinking of actually a good friend of mine who has been in actuarial science for we're basically the same age, so he's been in the workforce right out of undergraduate for 20 some years, and he keeps saying year after year, it's like, I want to get out of this I want to, and all it's all meetings all the time. It's like, I want to go into teaching. And I'm like, it's like, your paycheck is going to change he's making a lot of money. He's like, your paycheck is going to change substantially, but,
and you are going to have meetings.
Yeah.
Sorry.
There will still be meetings, but he burns the candle at a few too many ends. So I think he would get more work-life balance.
Yeah. That was another recommendation they made, which was you can also break the teacher salary down into amount they make per hour, which when you factor in the number of days in the academic year is a pretty good number. Like the students see, then are like, well, that's actually a pretty good number. Now that I kind of wonder if that plays into the whole myth of, oh, you only work 180 days a year. It's like, yeah, we know you don't really do that, but I need to go back and actually look at the math on that one.
It's a better way to look at it. It's more open-minded.
It is. It is a more open-minded way of looking at it in the sense of this is what people think your time is worth, and that is a good question. I mean, I know me, I never calculate my hourly rate because it means the more I work, the less I make per hour. So,
it's certainly one of the draws for the field of education. And I almost feel like more so even teaching in college that, and maybe this is my luxury for, not being tenure track positions, that when the summer arrives, that time is very flexible. And I often find myself wanting to think about my next classes and read books on education and all that over the summer. So I'm keeping busy with that, but there's no pressure to perform there. So I've, anytime I've had thoughts about, oh, maybe I'll do something else. Like, oh, then I have another summer where it's like, oh, I get a lot of flexibility. And I think, no, this is nice.
I actually have a lot of
satisfaction
fun
of working with students.
I actually have a lot of fun teaching summer classes, but we do all our fun like practicum for the student teachers. So we go run summer camp, STEM summer camp for 2 weeks with a bunch of our students. And it's not for the whole summer, so it really does still allow that flexibility. But I feel like a lot of the practical, hands-on learning in education, you can get more opportunities in the summer because you're not working within the school day and curriculum. And so students have a lot more freedom to try things out and experiment a little bit. Like when I say students, I mean my student teachers. They have more freedom to try out and experiment with their teaching. And then the kids have a really good time. And so that's been pretty fun.
Cool.
Yeah, I love the flexibility. Summer's great. And you can get research students or travel, go to AAPT summer meeting. Yeah.
So do we have any other further sessions we want to talk about, or Brian, I know you've prepared a couple of questions for us to think about, which is very nice. And we could hop into that.
Yeah. I did get to see a poster about the Quantum Party board game. This was specifically by the graphic designer.
Yes. Yeah. I saw that. I didn't get a chance to be at that session, but
she's a student. I don't think she has too much of a physics background. She was in charge of just the layout and the visual elements of the game and how to make this thing look sciencey, for lack of a better word. And it was interesting to hear from her about her interaction with the game of, okay, I have to make this thing look like you're playing with quantum mechanical cats. It was pretty neat.
And Anne, for your reference, I had mentioned this one last night as sort of it was the last session I attended yesterday and loved it, and want to talk to them about the game as well and try to get a copy.
I need to see this game. I still am thinking about the last in-person AAPT AAPT game night. Someone brought the Vector board game. It's like
Vector.
Oh my God. I still want to play that game.
It's fun.
We need to have a whole physics game night with these party. We have the quantum game. We've got the vector game. There's coding turtles. I mean, we could do all kinds of stuff.
I will never forget the AAPT game night where I brought Mysterium.
Oh, I've got that one.
You got that? And are you familiar with Mysterium?
No, but it sounds fun.
So for you, it's cooperative clue. So there is a suspect, there is a location, there is a weapon, but you're all trying to figure it out because one of you is the ghost of the person who was murdered. But you as the ghost are not allowed to talk. You only communicate through visions. And so you have this huge deck of vision cards. You draw 7 at a time, and you have to hand cards to people to help them zero in on the suspect, the location, and the murder weapon. And so they're trying to interpret these vision cards compared with the images on the cards. There's no words on anything. Like, you can play this game with someone you don't share a language with if you both know the rules. And so they're trying to compare the images on these cards, and the images are wild. Like, you'll have a Victorian era couple with a parasol walking into the mouth of a fish under a sky that's glowing with UFOs. Right. And so, like, there's something on there that the ghost thinks is related to the image on the card, and they want you to see that connection, but they're making other connections. And you have a limited number of rounds, you have a limited number of guesses to get everybody through all 3. And so we played, I think we had a full table. Like, I think we had the maximum number of players. I was not the ghost. I got to play that evening. I'm usually the ghost when we play with friends, but I got to just play that. I love playing the ghost, but I was glad to get to play. We played a perfect game.
Ooh.
8 strangers. None of us had met before at AAPT. The only thing we had in common was physics education. We played a perfect game. Everybody guessed everything correctly each step of the way, and we all succeeded on the final round.
I'm impressed.
And it was amazing. Just the fact that we all...
minds are equally deranged is
just the fact that we all have this mental framework that's been equally impacted by physics and education. We were somehow able to play this game perfectly.
That's kind of how I felt about the physics escape room that they had at AAPT.
Yes.
Ooh.
Oh my gosh, I went in there with a group of people that I knew from various aspects of my physics life, and we just oh man, we just blasted that room. It was so fun.
My group lost by about 10 seconds. We just didn't get the final thing entered in the computer fast enough, but we had everything solved.
We were down to the wire, but it was fun.
I've been so bad at having fun at AAPT meetings. We need to be back in person again so that I can try harder.
It's a critical bonding experience. I feel like all the great ideas are generated in those weird in between.
And we can have these game nights. That sounds
yeah.
That sounds lovely.